My name is Shafandi Frey, and my student ID is CS01084715.
And the last
The
one
last
is
person
me.
is Daniel Johan.
Yeah.
Yay!
Yay!
uh, all right, my name is Daniel Johan Ahmad, and my student ID is CS01085391. And a reminder, we are group 9, and this is assignment 4.
Yay!
All right, now to the MCQ. Uh,
Bro, let's
all
really
right,
watch this, bro.
all right. Who wants to start before
Just that, just that.
before I pick a wheel of names? Pick a wheel.
Okay.
You can
Okay,
start first.
Eh,
so for the first question, is what is the main goal of memory management in an operating system? So the answer is B, to allocate and manage memory efficiently. So
question. All
efficiently.
right, for number 2, which of the following memory management techniques lead to fragmentation? So for internal fragmentation, that would be fixed partitioning. C.
Okay.
And
Right.
continuing for question 3, which memory management scheme divides memory into equal fixed size blocks? And it will be B, paging.
Uh,
On to number 4,
on to number
next
4.
person.
Uh, yeah. So
Yes.
for number four, what is the main purpose of virtual memories in an operating system? The answer will be B, to allow program to run without worrying about physical memory limitation.
I love virtual memory.
No, you
Mm-hmm.
don't. That's a lie.
Hey, I can boast about having 64 gigabytes of RAM.
All right. All right.
Next question, next
Next
question,
question.
All right,
next
What
question
question.
is the
5.
term for when the CPU spends most of its time swapping pages in and out rather than executing instructions? That would be B, trashing.
Mhm.
Trash.
And for the final question, number 6, which of
Which
the
of the
following is all right,
sorry?
go.
No, just continue,
Okay, okay,
continue.
okay,
Sorry,
all right.
sorry for
So
interrupting.
for number 6, which of the following is a page replacement algorithm? That would be B, least recently used, or LRU. Now moving on to the fill in the blanks.
Fill
Yay.
in blank section.
Wow.
Who's gonna start first?
Alright,
Mm,
Okay. Okay, I'm gonna start first. So for the first question is the memory management technique that allow processes to be divided into variable size section is called dynamic partitioning. Okay, so for who is gonna answer for the second
for
question?
number 2, in the blank, memory is divided into partitions of equal or different sizes, and each partition can only hold one process, and it would be fixed partitioning. Fixed partitioning.
Damn.
And for number 3, the technique used to reduce external fragmentation by shifting processes in memory so that they are contiguous is called compaction.
Compact.
Compact.
Okay, for number 4, the concept that process tend to access a small portion of memory repeatedly over a short period of time is known as the not principle of locality. It's the locality of reference.
Locality of reference.
Yeah.
I
Okay.
see. So the
I
fifth
will
question,
I will keep referencing this pointer.
the blank policy determine when a page should be brought into memory. The answer would be fetch.
And for the
Who's
last
And
question,
last. Mm.
a blank is used to store recently accessed page table entries to speed up memory adjust translation. And that would be a translation look-aside buffer, or TLB.
All right, moving on to matching questions. Oh dear.
Oh, don't be so surprised.
All right, for the first one, paging. That would be the last one, divides memory into fixed size blocks. That would be paging.
this? So for the segmentation, So the second last one, the divides memory into variable size logical segments.
So the first one would be fixed partitioning.
Yes. Right.
And so for dynamic partitioning, it will lead to external fragmentation as its characteristic. Last
And the
one,
last one,
The last one is for buddy system, which splits memory into power of 2 blocks.
very buddy, huh?
Next one,
I
guys.
don't want to know that.
Oh.
Okay.
Alright, but the next, what do you call this? Table or whatever?
It's
It's
just
also
the
a
same
matching
thing. It's just
question.
matching.
Yes. Memory
Is the
management
question
technique to
matching again?
characteristic. The first one, paging. Where does that go? Divides memory into fixed size blocks.
Yeah, it's the
And
same thing.
Where
Same
did
as
that
the first
go?
question.
Quite literally the same.
Okay, so for the fragmentation, it will be the last one, divides memory into variable size blocks. And then for the page fall will be the second last one, the occurs when a requested page is not in the memory.
Page fault. Very
And
fault.
for thrashing,
last-
it will be excessive paging, causing performance degradation as its characteristic.
And
Last
the
one
last
is
and the
go
last
ahead.
one will be TLP. The
Look-aside.
the last the second
Translation
one,
look-aside buffer.
Look-aside buffer.
the high speed hash.
Okay.
Okay, now on to the subjective questions. Oh my god.
Oh no.
So
There's
question
so
one,
many.
list
This is
and briefly
getting
explain the 5 principal requirements for memory management. Memory management. Yeah. Alright, who wishes to start? We'll take one and then we'll just explain it, yeah? One by one.
Okay.
Who wants to start first?
Okay, I'll start first.
Very well.
So the first requirement for memory management should be relocation. And that is to adjust the addresses in a process so it can be loaded into different parts of memory.
Yeah.
Can I go next?
Go.
Go ahead.
So the next one will be has to be protection.
No protection for you.
Hey,
Okay then.
Oh,
Explanation
moving on.
is you can prevent processes from accessing each other's memory without permission,
Cable.
Okay,
and
so
not whatever
for
DJ just said.
okay for
The next one.
the third one, so the third one is for the principal requirements is sharing. So what is sharing? So sharing is allows multiple processes to access the same memory.
Slow down a bit. Let
Hold
Moise
down a
catch
bit.
up.
Let the man type. Let the man type.
Allow multiple processes to access the same memory. Yes.
Okay, next.
next will be the physiological organization. The explanation would be memory is organized as a linear one-dimensional address space consisting of sequence of byte of word. Sorry.
Mm-hmm.
Can it type keep up? We can. Sequence of byte
Give him a bit. Give him a bit.
or
Bytes or words.
Vital
Yeah.
words. And the last one is physical organization. It is where computer memory is organized into main memory and secondary memory.
Okay, say it again, because Moise is just
Computer
catching up.
memory is organized into main memory and secondary memory.
all right.
I'm
For
eating
question
so
number 2.
many fisherman's
So
friends.
that's 5. So for question 2, briefly explain the concepts of paging and segmentation, as well as their key differences in memory management.
Oh,
Anybody want to go
see.
first?
Okay, so
Right.
two concepts, paging and segmentation. So for paging is a partition memory into equal fixed size chunks. This process is also divided into equal fixed size chunks of the same size as the memory.
All right. The next one would be segmentation.
Mm.
So for segmentation, a program can be subdivided into segments, and each segment varies in length.
Very in
Segments
depth.
vary in length. Yeah.
Okay,
All
so for the
right.
For
differences,
this
This is going to
definition,
be a table, isn't it?
yeah.
Yes, yes, it
Mm.
is. You're gonna have to put it
Usually
into
you
a
have to
table.
make a table, so we just
wait,
Ah.
if I know how to make it, let's see.
Oh my God, there's a table.
That should be
How many
for
differences do we need?
3 by 3.
I
Three?
don't know.
3
3
by
by
4,
3?
yeah.
3 by 4?
Yeah, that was okay. 4 by 4 okay.
4 by 4?
Wait,
Oh, fucking truck.
3 by 3.
okay, 4 by
EJ,
4.
Uh,
Right.
okay.
EJ,
So
really?
we can put the
It's a
aspect.
4 by 4.
Wait,
You just
okay.
cussed.
Oh yeah.
I made a mistake.
Oh well.
3 by 3.
I just
Uh,
just
I-
go
4 by
just
3,
go
right?
for the 4
Okay.
by 4. It's fine.
Oh, don't worry. I can edit it and I can edit it later.
Okay.
Foreshadowing.
So
Foreshadowing.
we can put the aspect as well as the
As
two concepts, which is for
Mhm.
paging and segmentation.
Yeah.
So
for
for the
3.
first aspect that we're gonna compare with paging and segmentation is gonna be division type. So for paging, it divides memory into fixed size chunks.
All right.
And for segmentation is it divides memory into variable size segments.
For
Size
second aspect,
segments.
what we say?
What?
You
Go
said
ahead.
something?
Someone said something? What?
Afiq, go ahead.
Afiq?
Alright.
Go.
For the second aspect would be purpose. On paging, it
What is your
manage
purpose?
memory. It manage memory efficiently, avoid internal fragmentation. Internal fragmentation.
Wait, that should be external, right?
Avoid external fragmentation. Correct.
Okay.
Okay. For segmentation, it reflects logical division like a code. Logical division.
That's
Like a code.
logical.
Logic.
The Gaiaco.
Data instead.
Muiz, logical.
Oh, thank you.
Yeah. Logical.
And for the last
the-
aspect would
Shahid.
be for the fragmentation. So for paging, it would cause internal fragmentation. And for segmentation, it can cause external fragmentation.
Yay.
All right.
All right, moving on to question 3. Explain the advantages of paging over partitioning in memory management. Since this question is 4 marks, it seems we're going to need 4 explanations. Who wishes to start?
Okay.
What can paging do?
Okay. So I will start first. So first of all, for the first one will be eliminates external fragmentation.
Eliminates
Okay.
external.
So okay, so for the explanation will be the paging uses fixed size page.
Okay.
Okay.
So the memory can be fully utilized without gaps between allocations.
Fully utilized
Without
without
gaps
Between allocation.
between allocations. Okay.
For the second advantage,
So for the second advantages is efficient use of memory. Okay, so paging doesn't waste large unused space. It is only the last page might have some unused bytes.
okay.
We'll go
Okay,
for the
so
next.
for
For the third is simple allocation and management. Allocation and management. The explanation would be the memory is managed in similar page size. And it's but making location allocation and replace easier for OS. Allocation and replacement easier for OS.
Okay.
All right.
The last
So
one?
for the
Last one.
final one is it supports virtual memory easily. Supports virtual memory easily. So paging works well with virtual memory systems. And it allows processes to be loaded. Oh, okay. And it allows processes
Okay.
to be loaded
Hmm.
in non-contiguous.
Contagious. It's really hard.
Contiguous.
It's an
Okay.
equal.
Oh,
Non-contiguous.
non-contiguous.
Memory
Non-contiguous.
locations.
Mhm.
Memory locations. That's it.
Okay.
Okay.
All right,
That's
that's it for
it
question
for that one.
3. Moving on to question 4. Oh God. All right, for question 4,
Okay.
briefly
For
explain
definition.
the basic definition and the purpose of virtual memory. I suppose I'll start with the
So
definition.
yeah.
So for the definition, virtual memory is a memory management technique that gives the illusion of a large, continuous
Slow
memory
down.
space. Okay, I'm sorry. Okay, memory management technique that gives the illusion of a large, continuous memory space to programs, even if the physical RAM is limited. All right, who wants to do the purpose?
So for the first purpose, okay. So for the first purpose, it allows larger programs to run by using disk space as extra memory. Programs to run by
Programs to run. By
to run by using disk space as extra memory.
for the second purpose.
Anyone?
Okay, I'll do it then. For the
Alright.
second purpose, it can enable multiple program to run simultaneously. OUS. Okay. Without worrying about physical
Physical.
memory limits.
Mhm. I love multitasking. All right, the last one.
No, you don't.
Yeah. So
I
for the
don't?
last one,
Mhm.
it improves efficiency and multitasking.
Wait, why is it number 2?
Why is it number 2?
Why is it number
Yeah.
2?
Okay.
Okay.
Efficiency.
Improve efficiency. Okay.
And
Mhm.
multitasking. By loading
Loading.
only needed parts of a program into RAM.
All right. Okay.
Nice.
All right,
Should
that's
be
it.
To the last
Moving on
question.
to
To the
the question
final-
5.
Yeah, the
A
final
system
question.
is experiencing a high number of page faults, relatable, and performance has dropped significantly. That's me literally every waking minute. What is this situation called, and how can it be mitigated?
Mm.
So, anybody wanna give the
I suppose
situation
I'll
first?
start. I
Yeah,
believe the situation is thrashing because thrashing is what you call page faults.
Mm.
Page
Mm.
faults.
Okay.
So, how do we
Trash.
So how
mitigate?
can it
How do
be
we
the
mitigate this? Please,
Merely
I'd like to know.
decade. For the first,
I want
is
to know.
increase RAM.
Please.
Mitigation. Let's do
Standing
mitigation
Please,
is to
technique.
increase RAM.
please increase the RAM.
I'm not rich. So what if I can't increase the RAM? Second technique.
Is use better page replacement algorithm like LRU. What does that mean, Sean?
Least recently used.
Most of us just collectively forgot what LRU is.
Wait, jangan.
You know what it
Jangan
is.
hidung aku
You don't
berdarah.
know
I
the
know,
actual
it's just that I keep
definition.
forgetting.
Least recently
Huh.
used.
But the
Hey,
third technique will
shit.
be reduce the numbers. Third technique, reduce the numbers of running process.
You know, on Linux, all you have to do is sudo kill, sudo kill, sudo kill,
Okay.
sudo kill process.
Wait.
Okay, so
Algorithm.
that's enough.
Nice.
So
Alright.
running process like macam you kill the
Why is it
tab
doing
kan?
that?
One tab.
If you have Google Chrome open, close it.
Wow.
That's it. All right, that is
So-
the end for the subjective questions. So, sir, keep in mind this video will be in multiple parts, so we will have to do a cut here. Yeah, I have nothing else to say.
Wow.
Wow, amazing transition. I'm
Transition.
wow.
Transaction.
Transaction.
Ooh,
Transaction.
microtransactions.
You know what?
Let's go.
You know what? Y'all are
Yay, my
weird.
money is gone on gambling.
Bro, you know this is a recording, bro.
It's still recording, you know that. I haven't-
Transition.
You're gonna edit this part out anyway.
I'm gonna keep it in.
Good.
Yeah. All right, we'll actually transition now. And 3, 2, 1. Huh, huh, huh. All
Memang
right. We are now on the algorithm question.
So for the question 1, consider a system with 1 megabyte of memory using the buddy system. A. What is the first request that will fail in the following strings of requests due to lack of available memory? So for this request, we have 150 to 50K, and then 80K, 180K, 70K, 90K, 120K, and 130K. So how do we solve it? So I
Okay.
will pass it to Muiz.
Since this question is about buddy system, so we'll be only using power of 2 for the amount of allocation of kilobytes. So we got 64 kilobytes, 128, 256, and 512. Okay. So it first stated that the system with 1 megabyte of memory. So we know that 1 megabyte of memory is roughly 1024 kilobytes. So if we look at the first request, which is 150, so 150, we need to find the closest that is more than 150, which in this case is 256 kilo. So we take the overall total of memory and we just subtract with the amount that we allocate. Okay, anyone want to continue with the next request?
No one? Okay. So for the
DJ.
next request, it is 50K. So the part that is bigger than 50K would be 64. So from there, we go 768 kilobytes minus 64, which is equal to 704 kilobytes.
Okay.
And after that, the next request is 80K. And the block that is bigger than 80K is 128. So from there, same thing as before, 704 kilobytes minus 128 kilobytes, which is guys help me out. I can't math.
Neither
It's
can I.
around
576.
476.
Whip out the calculator.
500, sorry,
Fi-
576.
Huh?
576.
576.
Yes.
Okay, the next process.
So for the next process will be 180K. So the bigger that from 180K is 256K blocks. So we'll be using what 256K blocks. So meaning that 576K minus with 576K minus with 256K is around 320. Yes.
320.
Yes. And then
Can
we
I go
will
next?
okay,
Yeah,
sure,
Sean,
sure.
go.
Go,
So the next
go,
one is
go.
70K, and the closest one is 128K. So 320K minus 128K is, how much is this? 192K.
All right.
The next
So
one will be the 90K, which is 100, and the closest thing is 128K. So you have to minus 192 minus 128K, which is 64.
Okay, so the question asks to find that which of the first requests that will fail. So since we got 64 left, and the next request is 130K. Wait, not next request is 120K. So does it means that the process fails on 120K
Yeah.
because it doesn't have enough of the remaining memory to fit the 120K allocation. Okay, so that's question 1A done.
Mm-hmm.
For
Oh,
question
Next.
1B,
Mm-hmm.
I want to read the question.
So for question B, in the previous problem, at the time of the failed request, how much memory is wasted due to internal fragmentation and how much is wasted due to external fragmentation? Anyone wish to start, or is it just going to be me?
Okay, I'll start.
All right.
So
Yeah.
Yeah.
the question asked to, how much memory is wasted to two processes, which is internal fragmentation and external fragmentation. Okay.
Okay.
So for internal fragmentation, we just have to take the amount that we got for the first request, second request, third, and so on, and we just minus the amount that is more than that with the amount of with the amount that we request. So for example, it should be 256K. We minus 150K. That should be 106K.
Yep.
That is wasted.
Yep.
Okay. I want to continue with the next request.
So the next request is 50K. The amount that we allocate for it is 64 kilobytes. So 64 minus 50, that's 14 kilobytes wasted.
Next
so
request. Next request is 80, and the allocated is 128. So 48 kilobytes will be wasted.
Okay,
Alright.
so for the next one is 180K request, right? So we will see that it required 256K blocks will be minus with 180K. So the wasted is 76K blocks.
So the next request will be 100 to 28.
It's 70. It's
Oh,
70.
70K. 70, correct?
Mhm.
70K
So
and minus
request is 70K.
the next allocation is 70. The waste will
128.
be
But
oh yeah,
What?
what?
128.
58K.
Okay.
Yeah. 58K is
Yeah.
wasted.
Next one will be the request for 90K, and the allocated size is 128. So 128
Yes.
minus 90 kilobytes, which is
70.
38 wasted.
Bro had to hit the thinking pose.
I could not math.
Yeah.
So
So
these are all the requests that we managed to do, or the rest should be failed, so we don't count the last two.
failure.
So we need to add all the waste. So we can put total internal
15,
106
106, 14,
14K.
48, 76, 58, 38.
$340.
Oh,
I just used my calculator.
Damn.
we'll be fast, bro.
Yeah.
That's quick.
Okay, so that's for internal fragmentation. For external fragmentation, you just need to take the remainder of the memory that we get from the version 1A. So 64 here. So that means the amount of memory wasted for external fragmentation is 64K.
Mm-hmm.
Okay, that's it for question 1.
Yeah.
Moving on to question 2. Got
All right. Moving on to question 2. On a system using dynamic partitioning, assume memory is allocated as specified in the figure below before additional requests for 20K, 25K, and 10K in order are received. Determine which holes would be allocated to each of the memory requests using the following schemes by fill in the appropriate answer in the empty space. Okay, so for
Okay.
A, the first policy that we have here is first fit. Okay, so the first request is 20 kilobytes. Moving from the front, we immediately find a match, 22K. So the hole that we'll be using is 22K. So for the next one, move back to the front, 25 kilobytes. 22K is already occupied. 15K is too small. 20K is too small, which means we'll be using the next one, 40K. We'll be using the 40K hole. And for the last one, 10 kilobytes, move back to the front, 22K is used, and 15K is big enough. So we'll be using the 15K hole. All right, next one.
So for the next one, which is B, next fit. So for this one, it's almost like first fit, but after we start, we have to go to the right. We cannot start from the left again. So for the first one, it's also going to be 20K since the first request, since the hole has enough. And the second one, 15K cannot be taken because it does not fill in the request. 20K does not also fill in the request. And so the next one will be 40K for the request for 25 kilobytes. And the next hole for the 10 kilobyte request is going to be 45K.
All right.
Okay. The next one.
For the last one.
Moving on to the C, best fit. Okay, so for the first one, request of 20 kilobytes. So this one, we will pick which one is the best fit for each of the requests. So the first one will be 20 kilobytes. We will use whole 20K. And then for the 25 kilobytes, we will use the whole 25K. And then for the last one, 10 kilobyte, we will use the 15, sorry, my
The
mistake.
15K hole.
Okay, 15K. Okay, so yeah, that's the
Right.
best fit for each of the requests.
Okay, and we're done with question
Okay.
number 2.
All right, transition
Wow,
again.
that was fast.
Transition.
Moving on to
Wow.
question 3 then.
Transaction.
Whoa,
Let's
guys,
go
chill. This is
transaction.
what?
Woo.
We're not gonna do transition on each question.
Yes, we
All
are.
right. Anyway, moving on to question
Yes,
3.
we are. Pace and length for segment 2.
Okay.
And then below, write the offset, which is also 512 according to A. So I want you to go down. So offset equals to length. So this is a segment fault because offset cannot be. Okay, so go down again. The explanation is offset cannot be equal or more than or equal. More than or equal, sorry. Or more than length.
Okay.
So this will be a segment fault. So I'll also explain partially for B. So B is segment 1.
So I don't
Oh
know.
dear God.
Yeah.
Oh dear God.
Just write it.
Segment
Segment
1. Write the base and length of it also.
Okay.
And then go down, write the offset, just like so. The comparison is offset is less than length. Put a
Hmm?
and then just say it is valid.
A what?
It's valid.
It is valid.
It is valid.
This is the
Below?
validation part.
Okay.
Yeah.
All right.
So if it's valid, you have to add the base with the offset.
At the base with offset. Oh.
No, if
You
it's
have to-
valid.
Okay. Wait.
If it's
If
valid.
it's valid.
Offset, if it's valid, offset plus base. So that will be the physical address.
Mm.
So one of you, can you calculate?
Right.
So 330, 394,
330. Yes. 6 plus 2 is
394.
9. 394.
394.
394, yes.
394.
Okay.
Okay.
So that will be it for B. That's the physical address. That's
Move on to the C.
yeah. So just
Yes.
reference B. Go ahead.
Sorry.
Next person.
Mm-hmm.
Okay.
You can
So,
ask me, by the way, if you don't know.
Who's next?
Shahid.
Shahid.
So for the C, segment 3, the base will be 5,500. Sorry, 1,023.
Wait.
it is
What?
correct.
Wait, what?
550.
What?
Sorry,
Yeah.
5,500.
Yeah, it's
Sorry,
five.
5,500.
It's 550.
500, right?
It's
550.
550.
Sorry,
Okay.
sorry.
Left.
Okay, and the length will be 512.
What?
And
What?
What?
Oh my
Okay,
god.
Shahid.
Oh
Then
my
Wait,
god.
left,
Shahid,
Shahid, are you
segment
looking at a
3.
table, guy?
Shahid, segment 3. Segment 3. Row. Look at the row.
Look at the row.
Oh, sorry. Oh, sorry.
Look at the whole row.
Oh,
I think bro
Oh,
needs 2
sorry.
more eyes.
Okay, go on.
Man.
Offset.
Go on, go on, just go on.
Okay, so the offset will be 1,023. So
And now
is
they
it
give
valid? The answer is it valid? The answer
Yes.
is yes, because the offset is less than length. So yeah, it's valid. So what is the physical address? So if it's valid, the offset plus
can just
base, you
straight
will
add.
get the physical address.
Physical
so-
address is
So the
base
physical address will
plus
be
offset.
1573.
1573.
Wait,
Damn.
help me here.
Because
What do I need to add?
Okay,
550 plus 1020.
Yes.
Guys.
50
What?
plus
plus
10.
what?
Plus 10.
guys,
23.
guys.
1023. Okay, okay.
Yeah.
Yes.
That would be
Equal
1573.
1573.
1573.
1573.
All right.
Yeah.
That's the physical just for that.
Okay, so
last
sorry
one.
for
The last one.
Who hasn't gone yet?
I can go. Okay.
Yeah.
Okay.
Go.
First segment is 0. For the base would be 3,000. And the line will be 256. The offset will be 128. Yeah. So it is not valid because wait, no. It is valid because length is more than offset.
Offset is less than length. Okay.
Doesn't matter. It
It's
works
the
both
same.
ways.
I mean, keep it consistent.
All right. It is valid. Okay. Can someone calculate for me?
So the
Physical
physical address will
It will
be
be
6814. Oh God.
3,128.
3,000
Eh?
plus 128.
3,000. Okay.
Wait, it's offset
3,000
plus base.
plus
Yeah.
Okay,
3128.
3,108.
What it will be?
There we go.
Okay, we're done.
All right.
All right.
So,
That is all for question 3.
yep.
Another transition.
Whoa!
Alright.
Whoa!
Alright, moving on to question 4.
Whoa.
All right, we are now at the last part of the algorithm questions. Question 4.
Well, you're not gonna read it?
I'm gonna read it. Hold on. I'm catching my breath, bro. In virtual memory paging system. Wait, actually, references are made by a program to the following pages: 10234 2014302. Show the successive pages residing in 3 frames using replacement policies below. For each replacement policy, state find? What?
Yeah.
Policy state is the
Policy
state.
state. Find the number of page faults that occurs. All right. Who wants to start with FIFO?
So, for this question, we're gonna go to the
We shall
Excel
be
sheet.
using Microsoft Excel.
And so this is just pre-done, so you don't have to watch boring.
Mm-hmm.
So let's start off with first in, first out replacement, shall we? Is everyone ready?
Mm-hmm.
Let's go.
Yes.
So this is 1. So this will be 1, 0. So this will be 1, 0, 2. So since this is first in, first out,
That will be 3.
so
The-
this
The
will
one would
replace.
be out.
Yeah.
This,
Yeah, one will be out because there's only 3.
this is crap.
So, since this
Yeah,
is first in, first out, 4 is gonna be after 3. So 3, 4, 2. Anybody want to continue?
3,
What's this?
And
4,
then
0.
it should be the same.
Yeah. It's still the same. Because
Okay.
It
Oh, wait.
replaces the
Before
two on the
that,
bottom.
this
yeah,
is
yeah. There's still
fault.
2.
This is what is it? Page fault or fault page?
Fault,
Page
fault.
fault.
Page faults.
Before.
Yeah,
I
page
got it
faults.
backwards.
Ooh.
For this one, you got to
Cockroaches.
replace with 2.
Cockroach got utterly obliterated
But that-
somewhere in the toilet.
Page fault happens
So-
when it replaces a new number, right?
New
Yeah.
number.
Mm-hmm.
Okay.
For the
So
0,
this-
you got replaced with 2.
For 0,
Because
3, 4,
to
First in,
the
2
first
becomes
out.
0.
the old one.
2 was the
Fault
2 was
there,
the
and then for
latest.
1, 1 replaces 3, I'm guessing. Yes.
Yep.
Yep.
And this will be
And then
a
for
page
4,
fault. So this will
that's
be just the same.
Still the
Yeah,
same.
1, 4,
because
0.
We have 4 already.
So
So
this
That
will
will
be
be
1.
1, 3. 1, 3, 0. Yeah. And the last one is
1, 3,
Still the
1, 3, 0,
0.
same. Still the same.
Still the same.
And then that one is
1,
Replace
3,
with
2.
2.
1,
Is
3,
this
2.
right or wrong?
Mhm.
That's right.
That's
Wait.
That's right,
right.
yeah.
So what does the
Build
question
the
say?
shrine.
Find the
Dash
number of
rank.
Find the
page
number of
faults.
page faults. So how many
So
Fs are at the bottom?
1, 2, 3, 4, 5, 6. So there's
So for FIFO, there's 6 page faults.
6 F.
Press F.
Yeah, I'll just leave it at that. Anyway.
Yeah.
Let's go. For
All right,
next
for
one.
B.
Okay, so that's first in, first
The
out.
next one will be LRU. Least upper? I forgot.
Recently
Least
used.
recently used.
Least recently used. All right.
This recently terbelit.
So
Wow.
I'll just erase it from here since the start will always be the same to fill it
This
up.
recently used.
Indeed.
Oh yeah, I forgot to mention it's 3 boxes because of the 3 frames.
3
Three
frames.
frames.
Mm.
Yeah.
Yeah.
So let's continue on with wait, no, that's not it.
Say
Yoink.
are you? Yeah.
Eh.
Ah,
I don't care. No.
no.
Anyway,
Uh-huh.
so LRU replacement this time.
Mm-hmm. So
Least
that would be what,
recently used.
3?
Okay,
The
so
3.
so the tip is
Mm-hmm.
skip 2 and then find this one. So
Pick
this will
2,
be
find this
3,
one.
0, 2,
Or just replace
and
with
this will
one.
be yellow. So skip 2 again. So you find 0. So
3, 4,
was
2.
it 3? Okay.
Oh, skip 2.
Skip 2 boxes. Okay.
Right.
So 2,
That should be the
this,
same,
this,
right?
this.
It's
2.
supposed to be the
So
same.
P4 2 as well?
It just stay
Yeah,
lah.
no, it just stays, yeah.
Mm-hmm.
Yeah, it's just
Thank you for reminding
is
me. I actually forgot about that. 0,
0.
skip 2, 3.
So 0, 4, 2.
Yes, would you like some candy?
Take it to the candy
What the hell
shop.
was that?
Okay.
What?
Candy
So,
Man.
so
That's
again,
right.
And
1,
then 0,
skip
1,
2.
2.
That should be 4.
Replace
What?
by replace by 1.
Wait.
0.
Yeah, 1.
0, 1, 2.
Mm-mm.
The next up is 4. So what?
So
2.
1,
Replace by
so
2.
skip 2. Yep.
I should replace the number
Yeah.
2
Yeah,
with
1
4.
replaces 2. 0, 1, 4.
Actually,
This
I
is
still remember this. What? Is
You
in
do?
the class. Yeah.
So 3,
Yes.
4,
It's
1,
amazing.
1, 2,
0.
3. So
Okay.
it replaces 0. So it's 3, 1,
3,
4.
3,
0,
1,
4.
4.
0,
Okay.
0.
So 0, skip 2, got 1.
Holy shit,
So
that's 0.
3,
0.
0.
0.
And then the
0,
last
0,
one,
2.
2,
So
1, 2.
4,
Mm-hmm.
3, 0, 2, and then page fault again.
So how many Fs do we have at the bottom? 1, 2,
It's
2,
1,
4,
2,
5,
3,
6,
4,
8,
5,
I think.
6, 7, 8.
8.
8.
So
8,
there's
yes.
8
8 Fs.
8 page faults. So
Holy
last one.
moly.
Last
So
one,
the
C, would be what is it?
What is it?
Uh,
What is it?
uh,
the
What is it?
optimal, I think.
What?
Optimus
optimal
Prime.
replacement.
Optimus Prime.
Optimus Prime.
All right,
It's
bro.
Optimus Prime. Trust me. Trust me.
Yes,
Alright,
yes,
bro.
it can be
Optimus
trusted.
Prime.
Yes, yes.
Yeah, man. Trust me.
Ooh,
You can be trusted. Yes, yes.
Yes, Transformers. Yes.
Yeah. Yay.
Optimus Prime, bro.
Optimal replacement. Ooh,
Mhm.
ooh, how optimal do you wish for this to be? Ooh. Wow. What the
Well,
hell? What?
Wait,
It's too long.
Let's fix that.
can you drag?
It's fine.
There we go.
No.
Anyway,
Yeah, that's fine. Anyway,
So-
all right. How do we do this, Sean?
so optimal replacement.
Mhm.
So you have to plan ahead with what we have here.
Plan ahead.
So
Okay.
For example.
So seeing 420 over
Mhm.
here.
Yeah.
So we want to try and
420.
maintain these so it doesn't get page faulted. So out of
So you don't
so-
want it to page fault. Okay.
yeah, so you don't want it to page fault
Okay,
as
so you
much.
don't want it to page fault. Okay.
Yes.
So you have to look ahead and see how many like duplicates you can get. So for this, you're bound to have to switch.
Get one anyway.
So
So it's
zero.
302.
So we maintain.
The next one will be
So we maintain 02 because it's over here.
Mhm.
So we can skip these two.
Mm.
But unfortunately, we have
Unfortunately,
to.
we have
a
to replace
3.
before. Yes.
Wait, which means the next row is 402 then,
Hmm.
because there's a 4.
Yeah.
Yeah,
Unfortunately.
so it's another
but-
fault. Fault next to a fault. Amazing. And then these two remain.
So
This-
the-
these
this
two are
one for-
just
you can skip.
blank.
Yeah, you can skip these.
Mhm.
Next one, the
Oh.
1.
One.
Another 102.
So
Since you want to keep with 4, so 4.
so I'll let you guys decide
How-
which one.
What?
This might be
1,
I
4, 3,
think
02.
It's the same, yeah. You can choose
Yeah.
any.
Choose any lah, I think.
Wouldn't it also be 102 then?
So you guys said
It'll still be
choose
02.
any.
We're
Hmm?
choosing
Choose.
any?
Yeah,
No,
choose
Yeah,
any.
you,
for
yeah,
the
you guys
one-
are right. You have to
yeah.
choose. You have to choose any. So let's just go with this.
Just go for
Yeah, I'd rather choose the one that's already there, 02.
No.
So back to
Or
changing
02.
it back again.
The next one will be
02.
302, and then the 0 and 2 would remain the same.
302. And then 02 will be, so they remain. Doesn't
Yeah,
change
these
at
two
all.
remain the same.
This is just gonna remain. So
Yes.
how
So
many?
how
One,
many
two,
page
three,
faults do we
five,
get?
5.
So we got
5.
5.
5 Fs.
We got 5.
I don't give it
5
F.
Fs.
So
I don't give a F.
so for first in first out, we got
6.
6 page
6.
faults.
6.
For
LRU, we got 8.
LRU,
we got 8.
Recently released use.
LRU, we got 8 total.
8 faults.
And for optical
and-
replacement, we got 5 page faults.
Hey.
So congrats, we made it to the end.
Finally.
Nice one.
Is there anything else the question asked?
No, it's just the
State
number
the
of
number
page
of page
faults.
fault. Okay.
That's it.
Yep.
Yes.
Okay. Yay, we're
Alright,
done.
we're
Okay.
at the end
Yeah,
of the
we-
page. Sir, first I would like to apologize beforehand because the editing and the quality would be kind of horrible. But that's just how
But
it is.
that is to be
Six.
expected, yeah.
That do be how it went. Hey, whose idea was it to just have one person edit this whole thing?
You.
Exactly.
Ew.
Ooh-ah.
Hoorah!
Well, in any case, I would like to say thank you, sir, and we will see you in the next
Next
video assignment.
assignment.
Bye.
Bye.
Damn. Don't want to say bye to Sir Chen. Wow.
Shai, bye.
Oh, bye.
Wow. Oh, bye. Bye,
Bye.
sir.
I can stop sharing now. Bye.
Stop recording. Hehehe.